till now we have discussed two rules of thumb, both of which apply to volatile chemicals and vapors. The third rule of thumb is for particles in the air or aerosols, and it is called a potential hazard ratio. Unlike the case for the vapors in the first two rules of thumb, we don't really need to know any physical property of the aerosol. We only need to know its occupational exposure limit. So those are the cases in which this rule of thumb can be applied. So again, the steps to using this are we select the appropriate occupational exposure limit, and from the potential hazard ratio or PHR matrix, we find out the required level of control for this aerosol. And we compare the required level of control with the observed level of control. And just as before, for the second rule of thumb, we have these decision criteria. If the observed level of control is greater than the required level of control, we call it a category 1 exposure. If observed level of control is equal to required level of control, it's a category 2 exposure. And if the observed level of control is less than the required level of control, it's a category 4 exposure. And here's the PHR matrix. So on the left-hand column, we have the occupational exposure ranges, then the PHR scale in the middle column, and then on the right-hand column, we have the required levels of control. So if we have an OEL greater than 5 milligrams per cubic meter, meaning it's a relatively benign type of aerosol, not particularly toxic, then the required level of control is just general ventilation, 2 to 4 air changes per hour. And this is the PHR scale 1. If the occupational exposure limit is between 5 and 1, so it's getting a little bit more toxic, then we require good general ventilation. So we need 4 to 6 air changes per hour. If the OEL range is between 1 to 0.1 milligrams per cubic meter, now we need 6 to 8 air changes per hour. If the OEL is between 0.1 to 0.01 milligrams per cubic meter, the required level of control is capture. If the OEL is between 0.01 to 0.001, the required level of control is containment. And finally, if the OEL is less than 0.001 milligrams per cubic meter, so very highly toxic aerosol, then we need containment and secondary containment of this substance. So again, as before, we can first go about selecting an appropriate occupational exposure limit, and then identify the required level of control from the PHR matrix. So let's assume that in our example, the OEL is between 5 and 1 milligrams per cubic meter, and that means that we need 4 to 6 air changes per hour in terms of general ventilation. Then we identify the observed level of control, and we ask, is the level of control the same, more, or less than the required level of control? And we have our decision criteria based on this comparison leading to an exposure in category 1, 2, or category 4. So now let's go back to that scenario I talked about at the very beginning of this lecture of the bystander exposure to asbestos. So asbestos is an aerosol. There's particles suspended in air, and so we can apply the PHR, the potential hazard ratio, the rule of thumb. So since this is a short-term exposure and we are asked to look at the exposures when the administrative assistant spends less than 30 minutes in this work environment, we can apply the Cal OSHA short-term exposure limit of 1 fiber per cc which roughly corresponds to 0.03 milligrams per cubic meter. So 0.03 milligrams per cubic meter is PHR scale number 4, so it's between 0.1 and 0.01 milligrams per cubic meter. And it requires capture. The required level of control is capture. But as we observed during our walkthrough and in that description I provided at the beginning of the lecture, the observed level of control is just good general ventilation. There is no capture here. And so right off the bat, we can say that because the observed level of control is less than the required level of control, we are in a category 4 exposure even for the bystander.